by n matrices. Any n by n matrix. If your n is greater or equal to n, so you have more either equal number of rows in the column or more rows than column. Okay, if that's your A, if that's your matrix A, then it can be decomposed into U sigma V T. Okay, where U is a n by n orthogonal matrix. V is an n by n orthogonal matrix. By the way, this is VT, okay, V transpose. Okay, and the sigma, okay, is diagonal. Sigma 1, sigma 2, and so on to sigma n. Okay, because like this sigma is n by n, and remember n are not necessarily the same, but n is greater or equal to n, so we may have more rows, but if you have additional rows, they are zeros. They are all zeros. And this sigma 1, sigma 2, and so on, they are, they satisfy sigma 1 greater or equal to sigma 2, greater or equal to sigma 3, blah, greater or equal to sigma n, greater or equal to 0. So some of them may be 0. Some of them may be 0. I mean, if you have this SUV single variable decomposition, okay, and you define your sigma i's in this order, then this sigma matrix is unique. Is unique. So this single variable, so that's this is SUV, okay, SUV, single variable decomposition. Yeah, where is that? Okay. So the theory, the sigma i's determined by this factorization are unique and called the singular value decomposition. So, as I told you, these sigma i's, they are unique. Once you define their, relationship to be sigma 1 greater or equal to sigma 2, blah, 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 greater or equal to sigma n, greater or equal to 0. Okay, then these sigma i's, they are unique. We call that singular value decomposition. The rank of A equals the number of non-zero singular values. The rank of A equals to the number of non-singular values, non-zero singular values. So if A is n by n matrix, then A has a singular value decomposition. So we want to show that. To be honest, okay, this section, okay, I only plan to cover this one, okay, and let me quickly go to see the proof. There are 2 slides, and then there's some observations, okay, 2 additional observations and 1 example, and that's it. The closest matrix, this one, okay, I do not plan to cover it. This is actually like an application of SVD. And actually, some part of this theorem is out of scope. So I don't like it. I usually like, if I cover something, I would like to make sure that it's useful. You can get like the whole idea. But since like some part of this theorem is out of scope, So, okay, so we only have like 6 pages to cover, right? Okay, hopefully. But it's already a lot of stuff, okay? I don't know if I can finish. Okay, because we have like, less about 10 minutes for this lecture, and then probably another 20 minutes, okay, for the next lecture. And then it's a quiz time, right? So, if A equal to U sigma BT, then ATA equal to B sigma T sigma BT is diagonalized by T. Okay. First, ATA, remember, ATA is, the argument is similar. Because A is B sigma, B sigma BT. U sigma BT. So ATA is going to be this one, transpose. So it's going to be B T T, so it's going to be sigma T. And this is UT times this one, U sigma BT. So you see B sigma T sigma, this one, UTU, it's going to be identity matrix, okay, because U is, we previously already told you, U and V are diagonal matrices, orthogonal matrices, So this will result in I. So this is, we have sigma T, this is sigma, and V T. So you can see that ATA is diagonalized by B, okay, because this one, okay, sigma T sigma, okay, sigma is N times N, right? Sigma is N times N, and the sigma T is N times N. So first, this is N times N. This is N times N. Second, okay, this one we know it's like that. And when you transpose this, you get like diagonal like this. These are zero. These are zero. So as a result, okay, if you consider this is the diagonal, we call this D. We call this D. This is DT. So basically, it's the okay DTD. Okay. So this is like this is a diagonal matrix. So that's why, okay, ATA is diagonalized by B. Okay, because it's diagonalized by B, remember previously we just talked about this, okay, the A is so lambda 1 to lambda n, the eigenvectors of ATA, sorting in descending order. Okay, they are sorting in descending order. Okay, so lambda 1, blah, 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 greater equal to lambda 2, blah, 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 greater equal to lambda, and greater equal to 0. By the way, ATA, okay, their eigenvalues must be greater than 0. Why? Because there are a couple of things that I have to. If A, TA, okay, x equal to lambda x. Okay, here I'm claiming this lambda must be greater or equal to 0. How can I do that? Okay, let's consider AX squared. This is X T A T A X, right? According to the definition of the length, okay, and the inner product, like those stuff that we defined previously, very long time ago. So we have this, right? And this one, this is xt. This ATA, look at here. ATAX, according to this one, ATAX equal to lambda x, right? So you have lambda x. So this is going to be lambda times x squared, right? Right? So in other words, you can write lambda equal to AX squared divided by x squared. Of course, like x is like eigenvector corresponding to lambda. But because the numerator and denominator are both positive, right? So lambda must be positive. Okay, so that's why, okay, we can write like this lambda 1, lambda 2, blah, 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 these eigenvectors. We can solve them in descending order, okay, from lambda 1, blah, 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 lambda 2. I mean, they are greater or equal to 0. And the d1, b2 to bn are corresponding eigenvectors. Okay? And then with that, d equal to d1 to bn. Okay, with that like d1 to bn. Okay, we then compose the current vectors for v. Current vectors for v. Okay, and lambda, we let sigma I to be lambda I square root of lambda I. First, okay, v, if you compose v this way, how can you argue v is also is an orthogonal matrix? Okay. So remember, Vi, Vj, they are two different eigenvectors from of like ATA, right? We need to show that. Okay, because we want to show that V is an orthogonal matrix. Okay. Let's take 10 minutes break. We'll come back. We'll continue the discussion. Okay.
或自知之明啊，那个作业以外我应该写不出来。
我是已经交了。 直接进球，但可是他们那个好像就走过去了，不知道为啥。对对。可是他只要下面有字的话，你都不可能跟下去。他又不是认真做这个，他有图嘛？他说我是喜欢去拿CS嘛，喜欢。忘记你可以自己看影片，正常型。是不是你改的？对啊，可是我上次剪了5000多集，应该是你改的。
小光好像刚刚说要画关。